this is stuff you do already possess in your knowledge, but today is the relationship of stuff that you should already possess in your knowledge way back 5th grade, some of it a lot longer than that. All right, so let's start off. In your notebooks, which I'm going to have you turn in on Friday, is in the middle of your page, I want you to write the 2 words. I'll get all the way in a second. Counting numbers. Easy, easy, easy stuff here. And the reason why we're doing something as easy as this is we are going to define things very carefully. And the words that we use in math, because in anything we do in math or in English or whatever, words matter. When we're talking to people, words matter. And in math, words matter as well, because words mean what we're doing. So all your counting numbers are, and that's it if I write this in the middle of your page, because we're going to grow out of this. If you wrote it at the top, you're going to have a problem. That's why I said write it in the middle of your page. But it's noticed that a lot of people didn't write it in the middle like I suggested. So all your counting numbers are the numbers that begin with 1 and anything bigger than 1. And they're only whole numbers. I shouldn't even use that word, whole numbers, but they are the numbers 1, 2, 3, 4, 5, 6 until the end of time. To the end of time. It's an infinite amount, but only starting with 1. Okay, if you got that concept, draw a box around it. Just like so. So counting numbers. Now surrounding the counting numbers, our next level up is the whole numbers. And this is also a concept that's on the 7th grade and 8th grade NCHS. So
Where do we have ours?
in first week of May. All right, so the whole numbers are very similar to the counting numbers, except there's one more number involved. And that one more number is 0. So our whole numbers, excuse me, are the same as counting numbers with the addition of the number 0. Our next level up are the integers. And this adds a further layer. And when we talk about integers, we are talking about the positive numbers and the negative numbers. So if I start with 3 dots, my ellipses, -2, -1, 0, 1, 2, 3, ellipsis again to show that it goes on forever on both sides of 0. And the very last one that we're going to put up here are the rational numbers. And the rational numbers are the final layer. There are irrational numbers, but we're not going to worry about those today. Okay, then there's the rational numbers, which in the case of rational numbers include everything else. So you could have -3, you could have -3/2, 0, 1, 1.5, 2, so on. Decimals and fractions, mixed numbers, all that stuff is what we see when we talk about everything else. And that relationship is key. So, and it works like this. Is every counting number a whole number? Yes, because the whole numbers include all the counting numbers. Is every whole number an integer? Yes. Is every integer a rational number? Yes. If I start from the middle and work my way out, every counting number is a rational number. Every whole number is a rational number. I can work my way from the inside out, things are correct. If I work my way from the outside in, things are not. Is every rational number a counting number? No, because rational numbers include things that aren't counting numbers. All right? So looking at this chart, starting from the outside, the biggest one, the rational numbers, and I work my way in, I can't make a true statement. But if I start from the inside and work my way out, I can make true statements. Every integer is also a rational number, but not every rational number is an integer, is what I'm saying. And what that means for you is if you need to graph that type of thing, and you will be asked to do that several times, and if you needed to graph every number greater than -4, how could you graph every number greater than -4? And let me change that because I didn't specify what kind of number. Graph every integer greater than -4. Do integers include any fractions or decimals? Do integers include fractions and decimals? No. So if I needed to graph every integer greater than -4, then I'm going to put a dot. I'll change the color so you can see it better. I'll put a dot on every number on the number line I drew that's bigger than -4. But I am not going to draw a line on every integer greater than -4, so it's that. But I'm not going to draw a line. Why would I not draw a line? Why only dots? There's a reason. What do you think? Give me a guess. It's okay if you're wrong.
Would it include every number in between each number?
Correct. If I drew a line, it would also include every number in between. And that's not an integer then. Integers are only the numbers themselves, right? So that's why I represented the integers with dots and not a line. The only time I would draw a line at this point is when it specifies rational numbers. Okay? If I had a number line, here's another number line. If you were told graph the whole numbers, which dots would I use? Just graph the whole numbers. Looking at your chart, you should be able to know that. On that line, graph the whole numbers. Look at your chart and tell me which ones are whole numbers. 0, 1, 2, 3, and 4. Okay? And again, no line, because whole numbers do not include fractions or decimals. Okay? So I just represent that with dots. One more line to draw. Last one. Promise. New color. And this is going to clash horribly. Graph on that new chart, that new line I drew, all of the rational numbers bigger than -1. How would I do that? Everything bigger than -1. How would I do that? Any guesses? Would that be dots or a line? It'll be a line. I just drew an open circle over my -1. So I said it couldn't be -1, did I? So I said anything bigger than -1. You're not going to do this today, I'm just showing you. And I draw a line. So I said draw the rational numbers bigger than -1. I represent that with an open circle. Okay, so that's the concept for today. Just looking at the relationship. So if I go back to the chart, rational numbers are everything, including fractions and decimals. Integers are negative numbers and positive numbers and 0. Whole numbers are 0 and all positive numbers. And counting numbers are just the positive numbers without 0. All right? Any questions? It's a concept thing today, not a lesson type thing today. I will work with questions when I finish with everyone. You're dismissed.